Okay, good morning, everybody. Let's get going. Any quick questions about deliverable 3 that I can answer? Yes?
When you say facing up, do you mean like if this is the screen you're looking at it?
Yep.
Do you want to see the fingers facing you or the other way?
Ah, good question. So we want it, it's not a mirror. So you're not holding up your hand and seeing this. You're holding up your physical hand and you're seeing a virtual hand that does this, right? We want to make sure that everybody's giving the same kind of data. So it should be a one-to-one match between your physical hand and the virtual hand.
Wait, so you said it wasn't a mirror, but then when you displayed it, it looked like it was a mirror.
It does? Uh-oh. Okay, let's have a look.
You can just rotate the device around, turn it around.
What's that? Well, we want to make sure, we're going to be collecting data from everyone, so we want to make sure everybody's storing it in the same format. Okay, this is a good point. Let's have a look.
Yeah, same. But I have only Fridays, Sundays. I don't know what days I started it, and like the first step was to make it one module.
Yes.
And I did that.
Quiet down, everybody, please. Yep, in the back.
You use X and Z. I thought
Yep.
it was a flat one, but I don't know if in this one you want X and Y, so it's like kind of facing away.
Yeah, it's facing away, right? So the virtual hand looks like the physical hand. So as you can see here, I'm playing back some of my recorded gestures, which I'm recording my left hand and starting and stopping record with the right hand. Make sense?
I have a question, I guess, sort of about the future.
Yep.
At any point, will we be doing sign language letters that move or no?
The question is, will we be doing sign language gestures that move? No. But in the final 4 weeks, you can do what you want with your ASL gesture recognition system. However, at the end of week 10, we're going to have 59 instances of digits 0 through 9. And hopefully there's enough diversity in this class that when you have a new user come along and sign one of the digits between 0 and 9, your machine learning algorithm will recognize it. If only you are recording other gestures and someone else uses your system, it's going to be much harder for the machine learning algorithm to recognize that gesture. You can try it if you want. Could be an interesting experiment. Okay, I think actually part of the confusion about this is, are we asking you to capture X and Y or X and Z, right? I don't remember offhand from what's in the instructions. Does it say explicitly whether we want X and Y or X and Z?
You said X and Z in the second order, but X and Y in the third.
Okay, X and Z in the second deliverable and X and Y in the third?
Unless I misread it.
Okay, so whatever is written in deliverable 3, that's what goes, because deliverable 3 is where you're starting to record data. So if it's X and Y in deliverable 3, that's what you're capturing. If you have a look and it's ambiguous, send me a note. I'll update the deliverable and send around an announcement on Blackboard. But for now, X and Y. Any other questions? All good? Okay. Okay, thanks for that clarification. That was useful. Okay, so back to the lecture material. We're working our way through HCI design, and last time we looked at design in lots of different domains of human endeavor, starting with very subjective domains and gradually working towards engineering and software engineering, where things are very objective. When we sit down to design software, we usually start by writing down some functional requirements. The system will do this and it won't do that. So I'm going to develop a little bit of a hierarchy today to keep us oriented. We're going to try and, in the first step of design, write a description of the system, what it should and shouldn't do. That description is usually made up of functional requirements. We need to describe, when we build the hardware and software, what exactly should it do and what shouldn't it do. Last time we introduced this idea of non-functional requirements. So these are requirements that the system should have, but aren't directly about the function itself. What were some of the non-functional requirements we talked about last time? We introduced 4 of them, and we started to move along through them.
Efficiency and effectiveness.
Efficiency and effectiveness, those were parts of what we were talking about last time. I'll just back up. We were talking about efficiency and effectiveness, which are sort of, again, a deeper level underneath usability. So we were looking at these 4 general classes of non-functional requirements: accessibility, who can use the system and who may be unintentionally excluded from using the system. We finished last time by talking about various factors of usability. How easy is the system to use? How efficient is it? Does it have high utility? Can I use the system? I'm trying to get to point B. Can I use the system to get to point B? Or is this system not designed very well, so it actually kind of takes me to B prime? It's not quite what I wanted to do, but pretty close. We'll talk more about learnability and memorability in a little bit. Safety is important. And we'll talk shortly in a moment about acceptability. And finally, the most sort of subjective aspect of non-functional requirements, which is engagement. We'll talk about that in a moment. Okay, so we're taking these very general, vague concepts and iteratively unpacking them into more and more specific descriptors, and we're trying to march down to a level of specificity where we can finally start to measure these things. So we'll spend a fair bit of time when we talk about user testing about empirical measurement. What sorts of measurements might we use to decide whether a system is accessible? We hope that our system can be used by large numbers of people. We're not sure. We deploy our system out into the world as an app and people download it on their phones. We start to collect data back. What aspect of the data could we look at to measure accessibility? You could look at your demographics, right? Assuming people are willing to share that information with you, which they may or may not be. Absolutely, right? So we're going from something very vague down to something very specific that we can measure. Okay. I think I've already mentioned this several times now. In the Leap Motion project, we're going to be collecting data from 59 hands. But among that data set of 59 hands, there are going to be some minority subsets of data. What are those minority subsets? Lefties. What else? There's another important one that you will definitely come up against next week and the week after when you're trying to train your machine learning algorithm on this data set. Male and female, we're going to have a minority of small hands and a majority of larger hands. If you have a minority in your data set, if it's biased, and this is a big topic now in AI, if you have a biased data set, through no fault of the machine learning algorithm, it's going to have a hard time recognizing, dealing with, classifying the minority data set. So we may end up excluding some users from your system. Unless we compensate for that bias in the data when you deploy your ASL educational software to your friends and family in week 11, females are going to have a harder time using the system than males. Okay. We're going to, we finished last time by talking about the fact that some of these factors are sort of, they play against one another. They're antagonistic. If we're trying to make the system accessible as possible, we want to measure that through demographic information. We're asking people for gender data, right? So now maybe it's not acceptable to people because they don't want to share that kind of information. A lot of these factors, even if we can nail them down to specific measurable items, they are antagonistic. Okay. How do you know whether your system is usable? Sometimes we're collecting statistical data from users using our system. Sometimes we're asking them to just talk about the system. If we ask them outright whether you like the system or not, they'll say, yeah, it was okay, or no, it was kind of frustrating. That's not very useful data. You might step back and say, tell me about your interaction with our system. And there's hints in the way people use language to get a feel for whether they enjoy the system, whether it's actually working for them, or they're frustrated, and so on, right? Okay. Okay, so we're now going to talk about acceptability and engagement. These ones are harder to measure because they're a little bit more subjective. As I've mentioned several times now in HCI, we're often trying to play this balancing act between meeting our objective goals, making sure that our system conforms to what we want it to do, the actual functional part of the system, with other sort of subjective aspects of them. And acceptability is one of them. You may have a system that is perfectly usable, it's efficient, high utility, people can do exactly what they want to get done, but people don't use it. It's not acceptable. So one of the reasons that makes this difficult is it's difficult to alpha test or beta test your system in a controlled setting to measure acceptable, because people aren't using your system in a controlled laboratory setting. They're running your app on their phone while they're walking around outside, talking with friends, driving a car. They're using it in a particular context, and it may be that your system is not acceptable in that context. You can imagine some various features of acceptability. Do they trust the technology? Are there things going on in the greater context of the technology itself that you may not wish to trust the system? For those of you that have had the great fortune of using PeopleSoft, which is the HR software system for UVM, some people are laughing already, you'll know. Not necessarily very usable either, but definitely not very acceptable. For us poor faculty, we have no choice. So even if the system works well, there is already a baseline of resistance against this system. Okay. Is this system awkward? Does it force a different path from A to B than the user is used to? Before you deploy your technology, the user may have a particular way of getting from point A to point B. You introduce your system, it's perfectly usable, perfectly efficient, bug-free. It gets them from point A to point B faster, but it's not acceptable. A common example of this in the history of HCI is ebooks. It took a long time to get this right. Next time you're on a flight, look around. How many people are reading paper books and how many people are reading ebooks? From my count these days, it's more ebooks than books. So ebooks are finally starting to become acceptable. But it took a long time to get to this point. Why?
I think the efficiency and convenience of a book was never considered in design systems. Profitability was the first factor.
What was profitability?
Profitability.
Okay.
And so by that, they actually kind of damned themselves.
Who's they?
Any company trying to make a profit.
Oh, I see.
Adobe Acrobat Reader was a free system.
Ah, okay.
Creating, secure documents transfer between point A and point B.
Okay.
And so they already had the advantage.
Who had the advantage? Adobe because it was free?
Yeah, so they had to freely market their brand image against
Okay.
the user population that was trying to, anyone who's trying to penetrate the market.
So there was an economic advantage for the user for ebooks. It might have been cheaper than actually buying the physical book.
Right, but the medium was not one that was focused on profit, but one that was focused on just promoting the brand.
Right. Okay. So we're focusing here on usability. What is it about, acceptability? What is it about ebooks that was particularly difficult from from an acceptability point of view?
Well, I guess for reading off the back of the screen, like on the old tablet, is not as comfortable as reading off the page.
So what was it about the old tablets that made it not as comfortable as reading a physical book? It was the light, right? So it's the page is emitting light at you. So that's kind of been solved. What else? It seems like a detail on the surface, right? But it's extremely important. And I don't know if this still exists, but a lot of ebook apps, they actually create the illusion now of turning a page. And for some people, that's what makes the difference between picking up an ebook and picking up a book, right? That's an acceptability issue.
I think that's the tip that is way more subtle than that. If you know I have a book for a while, you should know, I'm going to chapter 7, you have to know right where that is, there's a little crease there.
That's it.
It's your book.
It's your book, right? Yeah.
It's not generic, you remember so many physical details of it. Digital copies, it's hard to remember everything about it.
There's at least for people that love to read, right? There is a large number of these subtle details, which are still not incorporated into ebooks and may never be, right? Think about your favorite book. You've probably had it for a long time. You know that that scuff mark on the book was from when you read it 7 years ago at the beach, and this mark on the book is from... It's not just about the reading experience itself, right? There's something larger that is extremely difficult to get right in ebooks. So some of the obvious things up front, like lighting and turning a page, those have been solved, but there are still these subtle issues.
Especially for technical books or books that have really great quality graphics, like a photography book or something like that.
Sure.
If you have like a favorite photographer and he goes like Strand Bookstore in New York, you can see really nice prints of photographs, but I wouldn't necessarily want that in an ebook.
Exactly, right? So if you're looking at an art book or photography book where the quality of the prints is extremely important, there's something also about the physical experience and the aesthetic experience about opening a folio and looking at fine scale prints that's difficult to get right in a digital medium.
For better or for worse, people often increase the font size, but that also increases the amount of pages you have to go through. So instead of being on like 100 out of 300, you're on like 500 out of like 1500.
That's a great example, right? So in terms of accessibility, easily being able to change the font size is really important, right? Something you can't do with physical books. That was something that ebooks got right? It actually made reading, or at least quick and easy reading, more accessible than physical books. But it also changes some of the acceptability issues. Right now the book is 1,200 pages long.
I think it can take a lot more damage than an e-reader.
Okay.
For example, on the beach, if you drop it,
Absolutely.
it's messed up or cracked, you lost it, but the book is stuck. That's all right.
Exactly. So a lot of physical context comes into play when thinking about acceptability.
One good thing that ebooks do have is for code.
Okay.
So in physical books, you can't click on the code sample and copy and paste it into a REPL.
Okay, so copying and pasting code out of a technical manual, absolutely, right? So when we sit down to spec out an ebook, it's what actually is the activity? Is it reading a novel? Is it looking at an art book? Is it consulting a technical manual? Those are all very different activities, which usually are grouped under the same heading of reading a book. What are some other examples besides ebooks where acceptability is particularly challenging? Cameras, okay, how so?
I mean, as soon as you digitize the method, and it's easily portable,
Yep.
and it's easily storable, it kind of creates fear among any population that's just exposed to it.
Okay, so the fact that suddenly it's so easy.
Right.
Okay. Photography is a good one, right? If you're a fan of photography, there's something about the physical act of the camera itself, like reading a book, that's lost when you suddenly have this black rectangle and all you have to do is press the button and it does all the rest. It makes things easier to take a good photo, again, depending on your definition of good. But the very ease itself actually militates against acceptability for a lot of fans of photography. Yes?
When touchscreens first came out.
Okay.
So probably a big shift to learning all the new gestures and kind of different actions you can do without any explicit messaging, I thought.
That's a great example, right? The acceptability of touchscreens.
I've heard a lot of people say that they would never get a self-driving car.
Okay.
They just like to drive.
There's a great example. Yeah, absolutely. The act of driving. It'll be interesting to see what happens when there's large-scale uptake of autonomous driving.
Digital instruments, and like Prince didn't want anyone to use Guitar Hero because he said discipline required to learn a musical instrument you wouldn't get from pressing notes on music.
That's a great example. An interesting recent example of this is a particular type of technology in which the better it becomes, the less acceptable it's becoming. Could be. Maybe there's many examples.
Maybe it's AI. It's more similar to human. It's more unacceptable.
Our AI and also social networks, right, which are now addictive, we've discovered, right? The better they are, the longer Facebook holds you on Facebook, the less acceptable it is to the general public, right? I mean, we're all still using it, but somehow it's not okay anymore, right? It's same thing with AI. The scary fact about how easy it's getting to use it, to code it up, to deploy it, for a government to deploy it, making the technology less acceptable. The more usable it becomes in that class of technologies, the less acceptable. That might not continue forever, but you can see these interesting social responses to large-scale technology. These have nothing really to do with the technology itself, maybe with the exception of AI. There were some technical challenges that needed to be worked out to get it to work. But it works, it's good. There's nothing wrong with the functional requirements, right? It's something else. That's where the HCI aspect of this comes into play. Okay, let's carry on. You'll notice a common pattern throughout this course. Some of these features of acceptability are kind of obvious, right? PeopleSoft is being forced on faculty and staff at UVM, so anyone could guess if they thought about it, there's going to be pushback to the system. That one's kind of obvious. Convenience, the convenience of reading a book, there's some things there that are obvious and not so obvious. Cultural and social habits come into play here. Is it affordable? Is it affordable to whom? The fact that sometimes the technology is cheaper or easier is actually worse, works against acceptability. Okay. Let's move on to the most subjective aspect of these non-functional requirements, which is engagement. This is the most subjective in the sense of we're trying to measure how much the technology pulls the user in. This is sort of the primary non-functional requirement for most computer games, as you could imagine. Very hard to nail this one down and measure it objectively. What we're trying to figure out is, does it pull the user in? Does it create a positive subjective experience for them? Do they feel a sense of immersion? Do they fall into the game or the software, whatever it is that we're trying to build for them, in the same way that people talk about good movies and good books, right? I got lost in a good book. That kind of language, again, gives you a hint about whether the system or the book or the software is engaging. Are they challenged or creatively inspired? For a lot of technology, we want the user to think as little as possible. We want the system to be as easy for them to use. We don't want them to think or feel challenged. But in some cases, like games or educational software, we want to bring them to the edge of expertise, right? We want to try and detect and bring them to that sweet spot between frustration and boredom. Difficult to get right because you need a system that can somehow measure boredom and frustration and tune itself accordingly. Does the user talk about time flying by when they use the system? Or does it feel like things are flowing from one to the next? Or are they being jerked from one level of the game or one level of the educational software from one level to the next? How do we go about trying to increase engagement? Again, a difficult thing to do because we're in a very subjective area now. But if you look at the history of design, Apple is sort of a master at this. There's certain design principles or rules of thumbs that come into play. Things that are engaging seem to fit, quote unquote, with the user somehow. They see their identity reflected, their identity or their philosophy reflected in the technology. Apple exploited this to great effect in their series of TV commercials about I'm a PC and I'm a Mac. Do people still remember these commercials? Or am I dating myself here? Okay, if you've never seen them, go YouTube, I'm a PC, I'm a Mac. Which of these two people would you rather be? Okay. All right, so I already mentioned adaptivity. So if we are trying to creatively challenge the user, we need to add this additional level of adaptivity, which becomes extremely difficult to get right. Is there a narrative to your system? If it's a computer game, that might be relatively straightforward to get right. You're leading the user through a series of levels. But is there a narrative arc there? Maybe sort of a relatively nebulous, unspecified sort of experience. It may be a sandbox game or an open world or a wiki where people can create things on their own. There is no real, by definition, start, middle, and an end. For a lot of people, that becomes disorienting and frustrating. I can't tell if I made progress with this system. I spent 2 hours with it, and I don't know if I'm any further than I was when I started. How do we help paint that picture for our users? Difficult thing to do. Immersion. So people talk about being drawn into a good book or a good movie. How does software and hardware go about drawing the user in? Users will often describe engaging experiences as, again, it seemed like time flew by. I seemed to effortlessly be able to do A, B, and C. So this is sort of a subjective experience that the psychologist Csikszentmihalyi spent quite a bit of time talking about. Wrote a very famous book called Flow. He looked at athletes and other performers at the peak of their ability in different areas and asked them to describe, when you played your best game of tennis, what was it like? What happened during that experience? And across very different domains, he realized he was getting back very similar stories from these top performers. Time seemed to slow down. I had plenty of time to wind up and hit the ball exactly where I wanted. It took no effort at all. How do we go about creating a system where users have that experience in the system? Again, difficult to say. It's a very subjective area. But let's look at these 1, 2, 3, 4, 5 design principles that we might try and maximize in our system to create an engaging experience. What are some examples of software and hardware that try to do this explicitly?
Like website usually congratulate you when you are the first year, second year.
Okay.
That's a progressive.
Exactly. So badges and points. And all. So which of these 5 is that addressing? It's an incentivization mechanism, right? You're incentivizing them to try to do something by giving them a badge. What is it?
Would you say that's identity? Like you're identifying with that level of engagement, or
Possibly. Again, we're in a subjective area here. There's no right or wrong answer.
I think I would argue that it's a narrative almost that demonstrates that you progressed in some way.
Absolutely, right? Badges are kind of waypoints, right? You've made it this far. If you've ever used Duolingo, which is the foreign language educational software, if you breathe, you get a badge, right? But it's very important, especially in an educational game, and this is going to be important for you in the last 4 weeks of this semester. It's not a lot of fun to try and get your hand to hold exactly right, to get the right gesture, let alone learn the gesture, remember the gesture. Learning is not always a pleasurable experience, right? So can we help the user along, right? We see you. We know that you have put in a lot of effort. Here's a gold star. You're now at level whatever. Right? That's a great example. Other examples?
I think we can build off the same principle or idea. Adaptivity is also a consideration when you're gamifying anything.
Absolutely. So we'll talk a fair bit about gamification. There needs to be a lot of adaptivity in there.
I know for the iPhone, they deliberately, when you do the ID,
Okay.
they deliberately made it like play.
Okay.
So it's so you're like playing to put your thumbprints to get your ID working.
Oh, I see that you got to
It's
match
like
up your, yeah,
it's
exactly.
like a childish kind of like how would you to make it fun. So it's not just like and you're putting in your thumbs. It's like plasticine almost like you're a child.
That's a great example. Gamifying just even recognizing a thumbprint. What about immersion? This one is kind of interesting, right? Up until relatively recently, there was a screen and maybe a speaker where you could see and hear things, but the technology was over there. I'm not in the game or in the system. Same thing, obviously, with a book and a movie. It's also distant from you, but if you've ever read a great book or watched a great movie, you feel like you're inside, right? How do we, creating good engagement is often about creating the illusion of.
So for the immersion, you can do like the Oculus or Guitar Hero, which sell physically inside as close as
So you mentioned the Oculus goggles for virtual reality. We'll spend a fair bit of time talking about virtual reality towards the end of the course in the looking inward part of the course. What is it about the goggles that draws you in? You're obviously wearing them, So the screen is closer to your eyes.
I'd say the most important factor in immersion is the progressive struggle
Okay.
through the events of the activity within that technology.
Okay, the progressive struggle, right?
Yeah,
You're feeling challenged somehow, keeping them right at that level.
Yeah, they definitely research this process, and certain things become less acceptable over time because of the results
Okay.
of this research.
Okay.
I mean, it started with like EverQuest and WoW, and then like MMOs have evolved over time because they realized the consequences of making it painful. So
Interesting.
That's too much.
Exactly, right? The addictive or the amount of effort needed to put in to progress, that's important. Let's come back to immersion.
So with the goggles, assuming the technology is good enough, whatever you're seeing is accurate, and you're only seeing what's on the screen, you're blocked off from what's around you, so your point of view is completely immersed in the game or software or whatever.
Absolutely, right? So you have this physical experience of putting on goggles. If you put on actual goggles that have a pane of glass, there's usually some obstruction here, and you're seeing through the glass, right? So when you put on the VR goggles, it casts the same illusion. So I'm expecting, as I wear the goggles, to have a similar experience to when I wear actual goggles or glasses or something else similar. Remember our discussion about when you're deploying new kinds of technology, and VR definitely qualifies. For a lot of people, they may be in the process of using VR for the first time. They have expectations about what's going to happen when they wear these goggles. What else is going on with VR goggles that helps to create this illusion that you're looking not at the physical world anymore, but this virtual world?
The way it responds to like moving your head.
The way it responds to the movement of your head, right? So there are sensors in the goggle that detect head orientation. In the real world, when I turn my head to the right, when I turn my head to the left, all of you flow to the right. The goggle detects movement of head to the left and updates the image so that everything in the image flows to the right. Right? Okay. That's one of dozens or hundreds of examples that need to be built into VR to be able to create the experience where suddenly the user goes from realizing they're looking at an illusion to feeling that they're actually in this virtual environment. Okay. Okay, so that's the end of our discussion about design philosophy and process. So we can talk about different kinds of processes, different ways to move down and try and measure and improve these things. We can elucidate lots of different design processes, and then we can argue about which of those processes are better, depending on our design philosophy. Regardless of which process you choose, there are certain design principles or rules of thumb that we want to try and use when we are designing our HCI system. One of those design principles is something we just talked about. No matter what the technology is, people are going to bring their experiences from the physical world to bear on your system. They have expectations when they're looking at something and they move their head about what the result will be. Right? Your software, whatever it is, should support those expectations as best you can. Yes?
On your slide for the non-functional, it said you had those four required criteria, plus
Yep.
etc. So what else falls underneath that?
Plus, etc. Good question. Okay, so it's, again, something that's not specifically about the function itself, but something that's beyond just the function, right? So the system, the user is frustrated with the system. Why? It may not necessarily be an acceptable, engaging usability or accessible issue. It's something else, right? So we're looking at this level for those other things. So that's what the etc. is meant for. There's other things beyond what we've talked about here that might affect whether someone chooses your system over another. Okay, so let's move on now and talk about design principles. So we know what we're trying to optimize, which are things that make the system desirable to the user. They might choose it over others. How do we sort of apply some rules of thumbs to do this? In the book, in the reading, it mentions helping people access, learn, and remember the system, giving them a sense of being in control and knowing what to do and how to do it safely and securely in a way that suits them. It's a mouthful. And again, full of a lot of vague terms. So we're going to try and take these terms, and we're going to gradually walk through in this lecture 12 features underneath here, 12 design principles that can help you improve the various non-functional requirements of an interactive system. Let's start again, as always, with some of the more obvious things, and we'll march in this set of 12 design principles to some that are less obvious. Let's start with visibility. So we want to make aspects of our system visible. If our system is a black box, the user is going to get confused very quickly. So the obvious thing we can do is obviously allow people to see what options and functions are available, display them in a way that makes them easy to remember, easy to learn. There's lots of ways of getting this wrong. What are some of the wrong ways of making a system visible?
When you have too much information,
Too-
you need to know everything.
Absolutely, right? So remember the Google landing page? There's a little bit of information there about what you can do on the Google main page, and that's it. The rest is white space, right? So we want to make the functions, we want to suggest how the system can be used by displaying various functions, but not too much. And again, on the surface, that sounds easy, but kind of difficult to do. Think about the system that you're developing with the Leap Motion device. Later on in the semester, you're going to put this device down in front of family members and say, have at it. The game is you're not allowed to tell them how to use the system. The first thing you'll probably want to do is the moment they bring their hand or hands over the device, they see this wireframe of a hand, right? The moment they see that wireframe of the hand, you've communicated a lot of what your system does, but maybe not everything, right? At some point, you're going to turn your system into an educational game. How do you signal to the users that they can actually learn ASL using the system above and beyond just waving your hand over the device?
I already have a line draw function. I assume there's some way to put text to the screen.
We could put text to the screen. We're going to assume for this course that whoever is using your system does not speak or read English. No paragraphs of explanatory text, because now we made the system overly visible. They've got to sit there and read the fine print before they use it. Probably not acceptable. How many of you read the tutorials for new apps? I don't know if they even make tutorials for apps anymore, right? It's absolutely unacceptable. So we're going to have to do it without text. So now we're back in HCI land, right? We're going to have to use visual hints to communicate how the system can be used.
On the dev page for Leap Motion, I was like just going through and watching a video. There's like a little robot that kind of shows, it's out of our scope, but it shows you what to do, and then you do it and mimic it. So it doesn't tell you anything, but it shows you exactly how to do it with its hand.
Absolutely. That's a great example, right? The little robot says do or show signals, doesn't say, do what I do. We've already mentioned that users bring their expectations about the physical world to bear on a new interactive technology. They also bring their expectations about social interactions. So the moment you flash up a little avatar or a robot, you're already signaling, bring your social expectations to bear on this. I'm a little robot and I'm looking out at the screen at you, right? Without any text, you're already setting the stage for what the user can expect. If this little robot or the owl or whatever it is, the avatar starts to do something, without having to say it, most users will realize it wants me to do what it's doing, right? Very, very simple. It's exploiting the social expectations that user brings to bear on the system. Okay. How else can we make the system visible aside from just showing things on the screen? We can move to sound and touch. Well, we can move beyond the example of Leap Motion now. What kinds of technology communicate information to you outside of the visual sense?
Your phone vibrates with a message.
Your phone, right? So you might have set your phone to vibrate if you receive a text message from a certain person, right? Maybe there's an emergency or something urgent that you're trying to monitor. It'll only interrupt you in those cases, right? Important to get those kinds of things right. For most of us, we're drowning in notifications these days. So with all the technology that we now use, it's a little bit too visible, right? People are trying to figure out how to make things less visible and how to tune our devices to only communicate the right information to us at the right time. Tricky to get that one right. We also want to try and make our system consistent, and this again goes back to this idea of expectations and prediction. You don't want a user having to try and relearn every new software system from scratch. There's some obvious consistent design features that are out there. If you download any new app, what do you expect to see when you start up the app? What are some things that have to be consistent across apps? Okay, right, so there's usually a splash screen or a login. You're usually not dumped directly into the app itself. What else? The app starts up and I see the splash page. I don't like this app. Exit. I want out. Get rid of it. Where do I go?
The close window.
The close button, right? And maybe that's on my phone itself, but usually the app has some sort of exit pathway. Where is the exit pathway? To the right? Exactly. Could we be more specific?
Or it could also be at the bottom.
Could be usually bottom center or upper right, right? Seemed kind of arbitrary. In the old days, as you could probably imagine, it was everywhere for different apps. So there's been this implicit convergence on certain consistency. One of the most recent ones is this icon. What does it mean? Menu, more, right? So these lines represent menu items. If you think about it, it's a very abstract ideogram, right? But anybody who's used technology enough, we all know about cascading functions and menu hierarchies and so on. It's all been condensed down in just the last few years to this, right? So the app is going to visibly show me just the stuff I need for now. On the login page, it's just how do I log in? It's going to hide everything else. And usually it's going to hide all that other stuff, quote unquote, underneath this thing. What are some other examples of consistencies across software systems and the physical world? What are some other aspects of apps or software or web pages that sort of build on our expectations from the real world?
We're all starting to follow like the same kind of design, like visual design.
Yes.
Like Google has their signature, like material, like assets and whatnot, and like that look is starting, like that simplistic look is starting to become more and more popular, I guess.
Absolutely, right? So most websites today, they're a lot much larger text, more white space, right, than it used to be. We're all converging to this sort of implicit consistency. Scrolling, right, exactly. I don't need to crowd all the information onto a page and make sure that you can see it all on the splash page. Most people now expect a little bit of text, a lot of white space, and if I want more, I'll go scrolling for it. Okay. Let's come back to, do you have a comment?
Or the rubber banding thing. I think that's cool.
What's rubber banding? That one I don't know.
Is, when you're on an app and you scroll and you
Okay.
hit the bottom,
Yep.
and you get that effect.
That it does what? That it bounces
tells you
around?
that's the end of it.
Oh, that it tells you it's the end.
So, yeah, you can't go any further. It's just
Rubber band. I get it. Right, exactly. It doesn't crash at the end. It sort of
Yes.
bounces around a little bit. That's a good one, right? Kind of subtle. Very nice. Very nice. Okay, let's come back. I forgot to mention something about visibility. So we want to make our system visible, but not too visible. So how do we help people recognize what's there in as easy way as possible? A lot of that, again, relies on visual design and having a savvy understanding of the human visual system. The human visual system is wonderful, works well for some things, not so well for other things. So let's play the photo game for a moment to drive home this point. I apologize for those in the back. How many differences between these two cartoon images? Okay, hold on to your number for a moment. So, in this tongue-in-cheek example, I am trying to communicate some information to you. I'm trying to make specific details visible, and those details are the differences between the two images. The whole point of this game is it's not made easy for you. Let's assume I want to make that information as obvious to you as possible. I could add some additional ink. I could draw circles around points in the images where there are differences, but I'm adding ink. Remember our discussion from Tuesday about trying to maximize the data to ink ratio. I want to communicate as much information to you as possible. I want to make various options or things visible, but I don't want to do so by splashing too much ink or too much detail onto the screen. So how could I go about making those items more obvious without having to add any additional ink?
Sort of fade out the rapacity of the spaces that are not different. Just only the differences are equal color.
Absolutely. So instead of adding, we could subtract, right? This is again a great unspoken design principle of, well, design in general, right? Less is more. Remove rather than add. For most people, their immediate instinct is draw a circle around. Add, right? Put arrows, put flashing arrows, add more instead of subtract. There's other ways we can do this. Same image. How many differences are there? I hear 12, 14. When I created these slides and was writing the text, I made a mistake, which I didn't see until I then made these two slides. There's actually two mistakes in the text. Did anyone notice that? I misspelled remembering, that's one. Then, right? Which you don't see because it's the same mistake in both slides. So we can try and present information in different ways. We can add, we could subtract, we could show the information in a different way. And this way is exploiting a particular mechanism of the human visual system that makes it easier to recognize the difference in details here. What is that detail of the human visual system that we're exploiting?
Is it persistence of vision?
Persistence of vision. Possibly. Can we describe it another way?
I think of it as like a frame rate. There's like a molecule that flips, and it only flips so fast. So 1/16 per second.
Maybe.
So you get this animation going.
Maybe. Motion, right? So for very good reason, the primate visual system immediately attends to movement, right, or change. You can't help it. If I were to leave this up for a few minutes, and I promise I won't, it's very hard to look away or pay attention to my voice. The movement inside the cartoon keeps bringing your eyes back. Your eyes saccade, or they move so that the exact point where the motion was detected lands in the center of your visual field. And you're seeing lots of those little localized pieces of movement. So your eyes are rapidly saccading around the image. So instead of you having to actively search, instead of saccading on this strawberry and then jumping to this strawberry and making sure that there is actually a strawberry there and jumping back, you're forcing yourself to do it. When we introduce the motion is doing it to your visual system, right? And that can either be annoying if it's an ad where there's someone dancing on the side of some web page that you're trying to read, or we could try and again exploit it because the user is trying to do something, which is find these differences, and we can make it easier on them by presenting the information in a different way. Okay. Okay, so related to consistency is obviously familiarity. We've kind of already mentioned this one. We want to try and use as much as possible things that the user is familiar with. And in cases where things are not familiar, we're trying to introduce some new concept or some new type of interaction with the system. We want to try and use a quote-unquote metaphor. We've already talked about visual metaphors a little bit. Imagine, and this one's kind of dated now, I guess. Imagine we have an icon on the desktop, and that icon points to a form, and you're supposed to be filling out the form. It's a long, complex form, so you fill out part of the form and close it down. There's another icon on your desktop, some other form you need to fill out. You're filling these out. We'd like to help the user step back, look at their desktop, all the forms, and get an overview for how far they are in filling out the various forms. How would you draw the icons? What might be a metaphor for filling up a form with data?
You could indicate like the level of completion within the icon itself. So like fade out the part that's not done.
We could fade out the part that's not. And when you first described this, you said filling up and you moved your hand from the bottom to the top. You're communicating a particular metaphor. What was it?
Empty is indicating, 0% completion, and then
Yep.
full is indicating, or at the top, indicating 100% completion.
Absolutely, right? So if you fill up a bucket with water, or you fill up a form with data, if you pay attention to the metaphor in the language there, you're filling it up, right? So we could use that and turn that into a visual metaphor to communicate that information. Whether you'd want to do so or not, I don't know, but that's the sort of idea, right? It would be strange if you had sort of an indicator where you're filling in things from the top down. Might be confusing. However, when you fill out a form, you're often filling data from the top of the form down. It's like the example from the beginning of the course of the series of the sign and innovation of first floor, fourth floor, or first floor, fourth floor. How about some other examples of visual metaphors? How might you try and communicate something that's unfamiliar with something that, through a metaphor, becomes familiar? Yep.
I was thinking one example is like they'll have a little like sound icon with like sound waves coming out of it.
Okay.
Like usually says something.
Okay, right. So turn on your microphone, or this requires audio. Other examples?
Just think of the old hamster wheel when everything was loading.
The hamster wheel, yes, that's the hamster wheel of death, right? When you see that turning, we'll come to this in a moment when we talk about control, it's a computer's polite way of saying, leave me alone, I'm busy, right? Which, again, can often make things unacceptable. It's becoming increasingly unacceptable for us not to be able to immediately seize control of the software, the app, at any time, right? In the old days, the spinning wheel, no problem, right? This is a computer, it's slow, it requires a lot of time to do whatever it's doing, no problem. We're becoming less and less patient with the hamster wheel of death, yes.
I really like the trash icon.
The trash icon, okay, there's an oldie but a goodie.
Yeah, it's an unlock of something that,
Absolutely, yeah. Tricky to get the trash icon right, because when you throw something in a trash bin, you can, in theory, take it back out again, right? Tricky, okay. Last one here, again, related to familiarity. We're going to talk about this idea a fair bit when we get to the psychology part of the course, is the idea of affordances, and this is an idea that comes from psychology. An affordance is an advertisement that an object projects. The object is trying to say something to you. So often in HCI design, we're designing icons, or the trash icon, or the rubber band at the bottom of the screen. We're trying to present something that's communicating or advertising an image. A little avatar that's looking into your eyes is projecting a particular affordance, which is, I'm paying attention to you, and I'm either waiting for you to do something and I'm going to respond, or I'm about to do something and I want you to respond, right? So it doesn't matter whether it's an owl or an avatar or a paperclip. It doesn't really matter about the shape or form of the thing. It's how the thing behaves to project or advertise that affordance. So again, in visual design, there's often, your first instinct is often to spend a lot of time on the physical form of the object or the icon or the avatar. Oftentimes, it's not the form itself that's important. It's how it moves or behaves and matches our expectations that we bring from the physical or social world. So let's have a look at a couple of affordances. We'll start with non-technical ones. Here's 5 images. Clearly, they all have very different forms. What do they have in common?
They're all seats.
They're all seats, right? It should take you, it's effortless, right? We can view that at the beginning. I picked these particular items because they highlight something interesting, not so much from HCI, but the history of computer vision. So computer vision in just the last few years has gotten very good due to millions and millions of images and some advances in neural networks and so on. But there was also a conceptual hurdle in computer vision for a long time, which is, how do we teach a computer to recognize chairs? Well, obviously, chairs have 4 legs and a flat area to sit on and usually a back. So let's write some code that takes an image and says, if there are 4 long things pointing down and a flat thing attached to the top of those 4 things, it's a chair. Otherwise, it's not. Works great for this example, not so much for this one. So we add another if-then clause inside. If it doesn't have 4 legs, but it has a central vertical shaft and then 4 prongs coming out vertically, then also it's a chair. Right? You can kind of see where this is going. Computer vision had a hard time for a long time getting going because there was a misunderstanding about how humans visually recognize objects. When you're thinking about affordances or chairs, if I were to ask you what a chair is, you might actually start to describe it geometrically. It's got a series of legs and a flat seat for sitting on and so on. And you're giving me the geometric description, but that's actually not what we're doing. You're starting with a geometry perhaps, but you're projecting yourself, your virtual self, into the image and asking yourself, can I sit in this chair? Or can I sit in or on this object? Or we can turn it around. From an affordance point of view, the object is projecting something which is, I am sittable. So one way to think about affordances as adverbs, right? They afford or they provide a particular action, which in this case is sitting. How about these 4 images? What's the affordance here? They're fuel, right? They provide heat, warmth, comfort, energy to us, right? And obviously I've kept one of the images the same. No one object has one affordance. The type of affordance that it projects is a function of context. What else is going on, in this case, literally around the image of the tree stump, right? We can have a little virtual owl that's looking out at you on the screen, and that's okay, but there's several affordances there. Possibly the owl is trying to project the affordance, teach me or show me. It's waiting for something from you. Or it's projecting the affordance, I'm about to show you something and teach you something. How do you, as the observer, disambiguate between those 2 affordances? Hopefully there are other things going on the screen or things that just happened on the screen that make it immediately clear what the owl is about to do or what it wants. Okay, so now let's have a look at some more HCI-related examples. What's the affordance of the virtual object that I've circled in red?
It's clickable.
It's clickable, right? That's it. That's the adverb I was looking for. Let's play the same game. I'm going to keep one of these objects the same. What is the affordance now?
You entered text.
You can enter text here, right? Some of them are cursors, some of them are buttons, some of them are entry bars. They're all sort of different from an HCI or sort of widget point of view, but they're all projecting the same affordance, which hopefully you realized immediately because they all have that one affordance in common, right? Again, the affordance that you see or that's projected by the object is influenced by what else is going on around it. What are some affordances you might build into your Leap Motion educational software? How might you show something on the screen which projects or advertises what the user should be doing?
I will put a picture of hand on it, so everyone knows that the hand is related to the operation.
A picture of a hand, a photo of an actual human hand.
Maybe cartoon one.
A cartoon one,
Yeah.
okay. So I see I never used Leap Motion device before. I don't even know what it is. And I see a cartoon hand on the screen.
Maybe you.
What is the affordance that it's projecting? Put yourself in the shoes of this naive user. They see a virtual hand on the screen. They see this cigarette lighter that's sitting on the tabletop.
Grab it.
Maybe grab it, right? So this is part of the design process, right? From the point of view of the user, what affordance is being projected by the combination of the physical device and what they see on the screen? Yes?
You could kind of do like the Wi-Fi symbol with a little flat thing at the bottom and then two things up top.
There's a great idea, right? The Wi-Fi symbol. So most people know that, at least in the Western world, this is not a volcano. It's a Wi-Fi signal. It means there's something wirelessly being projected from this thing. This thing, quote unquote, sees, right? And if you put a little virtual hand over it, this thing will see my hand. I have no idea what it does with that information or what about my hand it sees, but that is probably an unambiguous affordance. That's a good idea. That's the idea. Okay. All right, let's push on. We'll spend a fair bit of time next week talking about navigation, right? I'm at this point in the software. Where am I? Where have I been? Where can I go? Right? So communicating navigation can be challenging in certain kinds of software. We can obviously put up, a menu hierarchy here, the options that you have at this point, or you just got a badge, you passed level K, you can imagine where you're going next. You're going to level K +1. What are some of the creative ways that software systems you're familiar with communicate or give hints about navigation, where you can and can't go? Grayed out boxes, right? Anything that's grayed out is not available to you.
Sounds, like when you get this
You get the buzzer, right? You did something wrong, or you can't go there right now. Yep. Computer games historically have done a great job at this. Most computer games, if you're in a virtual world, not every object in that world is manipulable or pick-upable, or you can't walk to there. How do they communicate where you can go and where you can't go in computer games? Sorry, can you say that again?
Things you can pick up and you can talk to or kind of show you on the screen.
Okay.
Or leaving an area. I know some games will be just turn back and start flashing red.
Okay.
And you don't, it's over.
Absolutely, right? So it's flashing red, you're going in the wrong direction, right? That's another important part of navigation. Other ideas?
It's usually pretty common to build that in visually, design about the stuff. You can't go in that direction. Ocean or a cliff, it's not just you're going and all of a sudden your character just hits a visible wall.
That's right. They make it visible, right? So there's a cliff there, there's a wall, you can't go any further. In the early days of computer games, a lot of the objects had a light around them, like an aura. You could tell that was different from basically the background art. And that was something that you could interact with. It wasn't always obvious how you could, but you could, right? You could go over there and pick up or inspect that object. That over there is just a pretty picture. It's background art. Okay, we mentioned the spinning wheel of death already. Control is pretty important, right? Again, it can be very important if it's a real-time system, you're operating something. Who is in control? It should be at least visible who is in control at any time. At least the spinning wheel of death says, it's not you, it's me, right? The worst, one of the most frustrating experiences you can have as users, you're not sure who's in control, right? There's a lag in the video stream or the website, nothing's happening. Should you wait? Is it going to start moving again? Or do you need to reset or reload or turn off and turn back on? I don't know who's in control. In the early days of e-commerce, you were marched through these steps, and exactly when was your credit card going to be charged? And as that point is getting imminent, can I turn back? When can I cancel a charge that's about to occur to my credit card? Pretty important. Feedback, as you can imagine, this one's kind of controversial. We want to make the system visible and helpful, so we'd like to provide lots of feedback in different forms, as often as possible, ideally continuously. Do you agree? Disagree? Not too much. How much is too much?
So there's a really good example of a tweet I saw where a flight, when your flight is arriving, they give you, or it's changing, they give you notifications. But the particular app gave too many notifications, so it was like 23 within a half an hour.
Gotcha.
And a user doesn't want that much push notifications.
You're trying to get on a flight and it says it's been pushed back 2 minutes, another 3 minutes,
Yes.
another 3 minutes, another 3 minutes. Exactly. All right. Depends though. I can imagine there's some people that really care. It's tricky, right? Tricky to get this one right. Okay. Okay. Safety and security. Safety and security, this one's also tricky to get right in HCI. There's lots of different ways we can try and prevent the user from making mistakes or errors, and we can break them into reactive and proactive approaches. So proactive approaches, we're going to try and add constraints to keep people from making that mistake in the first place. There's a virtual cliff. I'm advertising to you up front, don't go over there. Retroactively, we're going to assume that it's allowable for users to make mistakes, but we'll make it easy for them to undo those mistakes after the fact. When might you want to use retroactive safety versus proactive safety? Editing a document, right? We'd like the user to have a sense of flow. You just go write or fill in what you need to do. And if you want, you can go back and correct things later, right? People have very different writing styles. Some people like to write very carefully. Others prefer, from a creative process point of view, to just write as quickly as possible and fix things after the fact. Imagine a word processing document that the moment you made a spelling mistake, you're not allowed to write any more text until you fix the spelling mistake. For most people, probably not very acceptable. Where do we want to be proactive rather than retroactive?
Like when you are browsing Google and you click on a link and it comes up with a page and says this might be impersonating the website, it's not secure, and you have to go through like 2 clicks to like actually get there.
Absolutely, that's a great example, right? We predict where you're going is dangerous, and we're predicting you probably didn't know that's where you're trying to go. We may be wrong, you may actually want to go there. We're just letting you know, right? The content, it might be unsettling for some people. You can't really undo it once you've shown the content, right?
When submitting a form, sometimes it feels necessary.
Absolutely, yep.
A good example where you can see both versions of it is learning to type programs.
Okay.
Some cursor will just keep going and everything you type will be wrong. Others will just stop dead. You'll stop it. Oh, I gotta go back and get the space key or whatever it is I missed.
Oh, that's interesting. So this is teaching coding?
Just regular typing.
Oh, regular typing, gotcha. Okay, teaching typing, that's an interesting example. Okay, so again, we need to think carefully about who's using the system, what activity are they performing, and in what different contexts. and that might dictate the way we go about trying to make the system secure or easily fixable, and so on. Okay. Last three here. We often want to make our system flexible because, again, we're going to have very different users using our system. For the beginners, we might want to create very long paths from A to B. So we have a system that isn't very efficient. There's lots of steps they have to carry out to get from point A to point B. But each of those steps is very visible, obvious, easy to recognize, easy to learn. So lots of short, simple steps. But for our advanced users, we want to allow large jumps. Each one of those jumps may be complex, but we're going to assume that in order for our system to be acceptable to advanced users, they don't want us to hold their hand, right? They want to run ahead. What are some examples of technology that provide those two different kinds of paths, and how do they do so?
When you are using the navigation system,
Yep.
there's some voice guide you to turn left and turn right, and you can set there's none, there's limited, there's normal.
Oh, for GPS navigation, you mean?
When you're driving a car. If you are new, you need a lot of details.
Yes, I guess that would count here. That's sort of more. That's about more or less notifications. What we're looking at here, where the system gives you lots of small steps or large jumps from one to the next.
Well, perhaps when you open like a JetBrains ID, it pops up a tips dialog.
Okay.
So the user might like that because it shows them more processes versus the advanced user just wants it gone.
Exactly, right? So it would pop up lots of those and say, here's sort of the tips about how to get from point A to point B. For the advanced user, get rid of it altogether. I know how to get there. Maybe that fits with your example as well.
Duolingo, again, you
Okay.
know enough of the language, you can jump to wherever you know, and you have to take a test to prove that, or you have to take a couple steps going up to.
Absolutely. So in an educational system like Duolingo, it's adapting, right? It gives you little mini tests and allows you to jump further ahead if you pass the test.
You can add stuff to your GitHub repository with the command line quicker, or you can just do it through the website by putting a couple of files.
Absolutely, right? So if you're new to Git, you might want to go to GitHub and click on things and do everything through the website, which takes a lot of clicks. Once you start to learn Git, you can do things locally on your own machine at the command line. That's a good example. Keyboard shortcuts, right? Menu hierarchies for the beginners, keyboard shortcuts for the advanced users. Okay, lots of examples there. Okay, style, this one kind of goes without saying. We want to make sure that it's attractive and clean, not too much detail. Last one, conviviality, designing for politeness. We want our software to be polite. It's interested in me. It doesn't put up the spinning wheel of death whenever it wants and gives us no notification about how long that spinning wheel of death is going to be up there. It's deferential to me. The moment I hit Control-C or Escape, the spinning wheel of death should disappear, right? I'm in charge, not it. It's forthcoming with information. If there's something I should know, it lets me know. It has common sense, anticipates my needs. It's responsive, gives instant gratification. It's taciturn about its personal problems. What does that mean? For the Windows users here, I don't know if the blue screen of death still exists. It flashes up an error and says, I'm sorry, you've hit error, and then gives some long hex code, which obviously you want to know, right? That's very important. We get that you're having a personal problem, something's gone wrong, but I don't need to know all the nitty-gritty details of what's gone wrong. For 99.9% of the users, I don't care. It's the only thing I care about. Something's gone terribly wrong with my machine. I don't care about the error code. What do I care about? Reboot, right? Be responsive and be forthcoming. What do I need to do? Do I need to give you another 10 seconds? Do I need to close the browser? Do I need to do a hard reset? That's the only thing I want to know in this moment, right? Okay, I think we'll leave things there for today. You have a quiz due tonight, and you have deliverable 3 due on Monday night. We'll talk about deliverable 4 on Tuesday. See you then.